Okay, dear students, welcome to the chemistry class. I hope you all are doing fine. As you already know, we have discussed photoelectric effect and black body radiation in the previous lecture, which tells us the particle nature of matter. One more topic which also describes the particle nature of matter is your atomic spectra. This topic again tells us the radiations is of particle type of nature. So, what is electromagnetic spectrum? When electromagnetic rays are arranged in order of their increasing wavelength or decreasing frequency, the complete spectrum obtained is called your electromagnetic spectrum. When we arrange the radiations in order of either increasing wavelength or decreasing frequency, then the complete spectrum which we obtain is your electromagnetic spectrum. As you can see, this is complete electromagnetic spectrum in which we have arranged the different rays in order of their increasing wavelength in meters or decreasing frequency per hertz. So you know the wavelength of cosmic ray is less and radio waves is maximum in all of these. And our main concern is about visible region whose wavelength is nearly 400 nanometer to 700 nanometer. 1 nanometer is equal to 10 raised to power minus 9 meter. Okay, so this is your complete electromagnetic spectrum. Now, before proceeding with atomic spectra, first we should know what is spectroscopy. As you know, the electromagnetic spectrum consists of radiations of different wavelength and frequencies. So the instrument which is used to separate radiations of different wavelength is called your spectroscope or spectrograph. If we use any instrument, the instrument which is used to separate all these wavelengths is your spectrograph or spectroscope or spectrograph. A spectroscope generally consists of a prism and also a telescope. Prism for dispersion of radiations and telescope to examine the emergent radiations. Fine. Now, first, you should know something about white light in atomic spectra. Atomic spectra is used to explain the structure of atom and also it tells us the particle nature of radiations. Okay. When we pass white light over a prism, this is the prism. I am passing white light over prism. Fine, dear students, it will pass through the prism and break down into 7 colors, which is your Vibgyor, the color of rainbow. You know, so Vibgyor means violet, indigo, blue, green, yellow, orange, red. When we pass white light through a prism, it breaks down into 7 colors and form Vibgyor. First, you should know what is white light. White light is a continuous spectrum. It is a continuous spectrum present in visible region. Continuous spectrum present in visible region whose wavelength is 400 nanometer to 700 nanometer. How can we say that it is continuous spectrum? Because when we pass white light through a prism, it splits into 7 color. Wavelength of violet is 400 nanometer and red is 700 nanometer. So it is a continuous spectrum of 7 colors. Find violet, indigo, blue, yellow, green, yellow, orange, red. So this is your continuous spectra of white light. And when you reverse back, all these rays pass through the prism, it again form white light. Fine, when we reverse all these rays and pass these rays to prism, it will again back converted into white light. Fine, so white light is a continuous spectrum of radiations forming 700 nanometer to 400 nanometer to 700 nanometer wavelength. Now, come to the atomic spectra. Atomic spectra, which means the spectra of atom, which is used to describe the structure of atom. Fine, atomic spectra is of two types: absorption spectra and emission spectra. What are the two types of atomic spectra? It is absorption spectra and emission spectra. So first we will discuss about absorption spectra. Absorption spectra. Dear students, when we pass the white light to a matter, we are passing the white light through any particle. Particle means either atom, ions, or molecules. How spectra will form when white light interact with matter? So some of the energies of white light is absorbed by the matter, and whatsoever radiations which is visible to us is our absorption spectra. Absorption, as the name suggests, something is absorbed. So whenever the white light is interacting with matter, so some of the rays are absorbed by the matter. Matter means either particle, ion, atom, or molecule. So some of the light is absorbed by the matter, and you will get one spectrum which is your absorption spectrum. For example, I am passing this white light through, suppose, any gas, cold gas. Then some of the radiations of white light is absorbed by this white light. Some portion is absorbed. Some portion is absorbed. Okay, and remaining portion, what we will get is our absorption spectra. As you know, white light is made up of 7 colors. So you will find, suppose this is the colored band. This is the colored band, and you will find in between the colored bands somewhat of dark bands. Dark bands represents those regions. You can see I am representing this dark band. Dark band represents those regions of the spectrum which absorbs the light. This is the continuous spectrum in which somewhat dark bands are present, and dark bands are representing those regions which are absorbed by the matter. So it is the continuous spectrum having some dark bands. These dark bands represents the regions which is in which matter absorbs these radiations, and the spectrum which we obtain from this is your atomic spectra. Okay, this is atomic absorption spectra. Dear students, if you feel any doubt till now, please let me know. Now our second type of spectra is emission spectra. Second type of spectra is your emission spectra. Emission spectra can be taken place when the atoms are present in excited state. Excited state means the electrons of the atom are not present in their normal state. Normal ground state means they have jumped to the higher energy level. So excited state is not the stable state. Fine. Excited atoms are not stable atom. Fine. Suppose your calmness is your basic nature and I make you angry. So how much time you can be in anger? Not so much of time. That is your excited state. You return back to your normal state. Fine. In the state of calmness. So this spectra is shown by those atoms, those states in which the matter is present in the excited state. And excited atoms are not the stable one. To stabilize, important point, to stabilize, they lose some energy. Fine. To convert it into stable state, they lose some energy by emitting radiations. And these emitted radiations is known as, this emitted radiations form the emission spectra. These emitted radiations forms the emission spectra. See what will happen. Suppose this is the gas, hot gas, because in this the molecules are in excited state. Fine. This is hot gas on losing energy. Fine. On losing energy, it emit radiations. It emit radiations and it forms the band. Fine. See like this. Suppose in this maximum portion is dark band. Maximum portion is your dark band. And in between the dark band, somewhat colored bands are present. See what is going on here. The atoms will move to the excited state by heating, by increasing the temperature, or by passing a photon to it. If we are incident light on any atom, its electrons will move to the excited state. Or if by increasing the temperature of that particular atom. So excited atoms are not stable atom. To stabilize, they lose some energy by emitting radiation. This emitted radiation forms your emission spectra. Now, I am giving you one example uh, in which I will explain both emission and absorption spectra. Suppose I am taking emission spectra and absorption spectra of helium atom. Okay. Emission and absorption spectra of helium atom. Suppose this is absorption spectra and this is emission spectra. This is emission spectra. In emission spectra, you will see the maximum portion is dark bands and in between the colored bands are present. In absorption spectra, mostly is the colored bands and maximum rest is your dark band. Fine. Can you differentiate between these two? Dear students, you will be surprised to know that the lines missing in the absorption atomic spectra are the lines, are the colored lines found in the emission absorption spectra. This is most important conclusion. Whatsoever lines are missing in the, whatsoever dark bands you can see in absorption spectra are the colored bands in emission absorption spectra. Okay. So if I will ask differentiate between emission and absorption spectra. So emission spectra is obtained when the radiation from any source is directly analyzed in the spectroscope. We are directly passing it to prism or any other thing or any other instrument. Absorption spectra is obtained when the white light is first passed through substance and then the transmitted light is analyzed in the spectroscope. Absorption spectra, it consists of dark lines in the otherwise continuous spectrum. Fine, you can see it is a continuous colored spectrum and in between dark lines are present. And here colored lines are present in between the dark bands. Emission spectra can be continuous or discontinuous, but absorption spectra is always discontinuous in nature. Dear students, till now, is there any doubt? Please let me know. How this atomic spectra is helpful in determining the structure of atom. Okay, now we will see this thing. How this atomic spectra helpful in analyzing the structure of atoms. So first structure was which was analyzed by Balmer scientist is hydrogen spectra. He see the hydrogen emission spectra. Dear student, emission spectra is unique for a particular atom. I repeat, hydrogen emission spectra is unique for a particular atom. That's why it is helpful in determining the atomic structure of a atom. So first, Balmer was the scientist. He see the hydrogen emission spectra. What he found that when hydrogen gas at low pressure is taken in the discharge tube and the light emitted on passing electric discharge is examined with a spectroscope, fine. So the spectrum obtained is called emission spectrum of hydrogen. What he found that it consists a large number of lines which are grouped together into series named after the discoverers. Like Balmer found some of the lines in hydrogen spectra and he gave some simple expression where wavelength of that line, or you can say that wave number, is equal to 109677. This is one constant. He gave the simple expression into 1 over 2 square minus 1 over n square. He gave the expression for Balmer series of hydrogen atom where he represent this equation. Fine. N to n square is your that limit where this rays can jump. Similarly, along with Balmer, so many scientists are also doing work on the hydrogen spectra. So there are different series like Lyman, Balmer, Paschen, Brackett, P Fund, and Humphrey series is also there. But in our syllabus, we have to deal with this level. So Lyman series is according to this wavelength or wave number is equal to 109677 into 1 over n1 1 over 1 square minus n2 square. And for Balmer it is same, but in this expression is 2 square minus 1 over n square. In Paschen everything is same, but here 1 over 3 square minus 1 over n square. In Brackett, everything is same. Here 1 over 4 square minus 1 over n square. In P Fund, everything is same. 1 over 5 square minus 1 over n square. These are the different lines found in the atomic spectra of hydrogen atom. So at last, Rydberg was the scientist who gave the general expression. And what was that expression? It was wave number is equal to R over 1 over n1 square minus n2 square, where the value of R is 109677 per centimeter. And R is your Rydberg constant. It is the general expressions, Rydberg's constant. Dear students, it is for hydrogen atom. If you find hydrogen-like particle, then multiply this term by its square of its atomic number. For hydrogen, atomic number is 1, but for other atoms, it is not 1. So it is the complete expression. Wave number is equals to Rydberg constant into this minus this. Okay, this is the value of Rydberg constant. Fine. Dear students, till now, is there any doubt? Please let me know. Please let me know. Okay. See one numerical. It is your NCERT in-text question based on the same topic. Question is, what are the frequency and wavelength? You have to calculate the frequency and wavelength of a photon emitted during, you have to calculate the frequency and wavelength of a photon emitted during a transition from, during a transition from n is equal to 5 to n is equal to 2. Electron is jumping from this region to this of hydrogen atom. Question is clear to you? So use that formula. Here n2 is 5 and n1 is 2, and wave number is equal to what? One Rydberg constant into 1 over n1 square minus n2 square. Put the value of this. It will be 109677 into 1 over 2 square, that is 4, minus 1 over 5 square, that is 25. Then you solve this. When we solve, it nearly comes out to be 109677 into 21 by 100. When you solve this, or 23032 0.2 per centimeter. But dear students, we have to calculate the lambda. So lambda is equal to 1 over wave number. So it will be 1 over 2303.2. Now wavelength is clear to you. Again, one thing, frequency. As you know the formula, what? C is equal to nu lambda. C is speed of light, which is 3 into 10 raised to power 8 over what? This wavelength. 1 over this means into 23032.2. Okay. Convert it into meter because this is meter per second. Okay. So in today's class, I have discussed about the atomic spectra. Atomic spectra is produced when any matter interact with the light and we obtain the spectrum. Fine. So white light is your continuous spectrum of visible rays having wavelength 400 nanometer to 700 nanometer. When white light is passed through a prism, it splits into 7 colors and form the Vibgyor, where violet color is having least wavelength 400 nanometer and red color is having 700 nanometer wavelength. Okay. And now atomic spectra is of two types, absorption spectra and emission spectra. Absorption spectra is that when white light is passed through a matter, some portion of the light is absorbed by the matter and the remaining portion which we get is our absorption spectra. Absorption spectra is your continuous spectra including somewhat dark bands. Okay, it is always discontinuous in nature. Emission spectra is found for excited atoms. When the atoms are present in excited state, and you know the atoms in the excited state are not stable. So they return back to their normal position, normal state, ground state by releasing energy. And after releasing their energy, they emit some radiations and we obtain the graph for that radiations, which is your emission spectra. Emission spectra is including dark bands in which somewhat colored bands are present. And the lines present in the dark lines present in the absorption spectra or the lines missing in the absorption spectra are the lines present in the emission spectra. And emission spectra can be continuous or discontinuous, and emission spectra is always unique for a particular atom. This property is used for determining the atomic structure of atom. So first, a scientist explained the structure of hydrogen atom by giving the Rydberg formula, which is nu bar or 1 by wavelength is equal to Rydberg constant into 1 by n1 square minus n2 square. Fine. And for hydrogen-like particle, it should be multiplied by the square of the atomic number. That's all about your today's lecture. If you feel any difficulty, then please message me or tell me.